When installing primary service conduits on a roof leading to a penthouse substation, you need to account for conductor derating due to ambient temperature and potential heat loss from the conductors themselves. It is crucial to understand that the order in which you perform the derating calculation and the heat loss calculation does not ultimately matter. The final, correct ampacity of the conductor will be the same regardless of which calculation is done first. The National Electrical Code, or NEC, mandates that conductors must be derated when installed in areas experiencing high ambient temperatures. Roofs, particularly in sunny locations like Florida, are prone to significant temperature increases, and this necessitates ampacity adjustments to prevent overheating and potential insulation damage. Derating factors are determined by the conductor's temperature rating, which indicates its maximum safe operating temperature and the surrounding ambient temperature. These factors are typically presented in tables within the NEC, like Table 310.15 Bowen or similar tables. They provide multipliers that reduce the conductor's allowable ampacity based on the difference between its rated temperature and the actual ambient temperature. For example, if a conductor is rated for 90 degrees Celsius and the ambient temperature on the roof is 50 degrees Celsius, you would consult the appropriate table to find the corresponding derating factor. This factor, which will be a value less than 1, is then multiplied by the conductor's original ampacity to determine its derated ampacity. Heat loss calculations, on the other hand, address the heat generated within the conductor itself due to the flow of electrical current. This heat generation is known as I²R loss, where I represents the current in amps and R represents the conductor's resistance in ohms. The amount of heat lost from a conductor is influenced by several factors, including firstly the conductor size. Larger conductors have lower resistance and thus generate less heat for the same amount of current. Secondly, the current flowing through the conductor. Higher currents lead to greater heat generation. And thirdly, the ambient temperature. Higher ambient temperatures reduce the conductor's ability to dissipate heat. To perform a heat loss calculation, you would need to know the conductor's resistance at its operating temperature. This information can typically be found in conductor specifications or calculated based on the conductor's material and dimensions. You would also need to know the actual current flowing through the conductor under normal operating conditions. Once you have these values, you can calculate the heat generated using the I²R formula. The resulting value represents the amount of power dissipated as heat, typically measured in watts per foot or meter of conductor length. When both derating and heat loss calculations are necessary, it is important to use the derated ampacity value in the heat loss calculation. This means that you first determine the conductor's ampacity based on the NEC tables and any applicable derating factors for ambient temperature. Then, you use this derated ampacity value as the maximum allowable current when calculating heat loss. This ensures that the heat generated by the conductor does not exceed its capacity to dissipate heat, even after accounting for the effects of ambient temperature. For example, suppose you have a conductor with an initial ampacity of 100 amps. After applying the appropriate derating factor for the roof's ambient temperature, its derated ampacity is reduced to 80 amps. When performing the heat loss calculation, you should use 80 amps as the maximum current value, not the original 100 amps. Using the derated ampacity in the heat loss calculation prevents the conductor from being overloaded and ensures that the heat loss remains within acceptable limits. This helps to maintain the integrity of the insulation and prevent premature aging or failure of the conductor. In summary, when dealing with primary service conduits on a roof, remember that firstly, the order of derating and heat loss calculations is not critical. The final result will be the same. Secondly, always consult the NEC for applicable derating factors based on conductor temperature rating and ambient temperature. Thirdly, use the derated ampacity value in heat loss calculations to ensure accurate results and prevent conductor overloading. By following these guidelines, you can ensure the safe and reliable operation of your electrical system in demanding environments. Always consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and regulations. Always remember that proper conductor selection and installation are critical for electrical safety and reliability. Neglecting these factors can lead to overheating, insulation damage, and potentially hazardous conditions.